I'm going to record to the cloud. Okay. All right. So this is what we're going to end up with here, this bottle. And all right, by the way, my Zoom is minimized. So if you do have any questions while I'm doing this, please jump in and make yourself loud. So this is what the bottle will look like at the end. And one thing that is really important, especially for the next part of the exercise, is that it is hollow. Okay, so I'm going to actually move this to this hidden layer here. Once I get that, yeah, I'm going to change that to the done layer. I'm going to close that. So now we're going to bring up the curves. Okay, that's the surface. Okay. Actually, I wonder if you know what I'm going to do? I'm going to just open a new one of these. If we go to the help menu, we bring up our, our tutorials panel. And let's see, I'm going to save that. But now I'm downloading. So this is what the file looks like when you open it up. And I'm going to put up the layers panel because that's important. So here's the schematic, but you really don't have to work with the schematic. What you can do is you can just work with the curves and the instructions. So you open the squeeze bottle, and that's what we have here. And and they talk about drawing these curves. You can actually use the curves that are already in it. Okay, so we've got the ellipse, we've got these. So these curves are already done. So what we're going to do is the first thing we're going to do is we're going to make the inside bottom of the bottle. We're going to go planar surface SRF. Okay, and now I have a surface there. That's great. Then I'm going to use the sweep to command, and the sweep to command is important. I'm going to move this over a little teeny bit. The sweep to command. We use this a lot. Sweep to, enter. So the first rail will be the bottom. The second rail will be this top. Okay, now it's asking for select the sweep shape. We're going to use that side one. And this is all good. We want it to be a closed sweep. We hit OK. So that is the bottle there that we've got. And then we want to blend the surface on the bottom. By the way, there is this is another one of those examples where we want to go through here and Rhino's instructions here actually skip a step after this. So I think it's important that you follow along with this instead of just following the instructions. So what we're going to do is we're going to use blend surface, and that's BLND SRF is the command. Select the first edge, we'll take that outside one. Second one, we'll take the inside. And once we choose that inside one, we have those, the little orientation, the seam point. We leave them as they are, especially if they're facing the same way. That's fine. We're going to hit enter. And I don't know if we really need to adjust it much. We can see what we have here. We can maybe adjust that a little bit. See how there's a little like curve there. Let's see whether we can flatten that down a little. That might do a little better. Yeah, there we go. Okay, that's good. I'm going to hit OK. Now that blend surface, now we have this surface, and this surface. These are not connected. And I think that the way that McNeil's instructions go, they think that they are. And then they tell you to cap. So what we really need to do first is we need to make sure that all these surfaces are joined. And it does, actually, it does say to join in there. But let's do that just to make sure. And you can do that with Control J. You could type in the word join. You can hit the button over here. So the join command broke history because I always use history at home here. So I'm going to click on this, and now it says to cap. So because we have a planar surface here, all we have to do is type in the word cap. And now this is a closed solid poly surface. And we can tell that when we hit the select button. So there we go. We have that. Now the next thing we want to do is make the surface for the label. And we have these straight lines. We have like these other lines here that we have. They gave us some slightly different ones, and we're going to use those. But before you, because the instructions tell you to make these straight lines, and they have this nifty little curvy one here. So we're going to use that instead. The curvy one is in the middle, but the straight one, or straighter one, is on the outsides. Or is it? No, actually, it's just the opposite. We're going to take this curve, we're going to mirror it so that we have it on both sides of the bottle. Okay, so now we have 3 curves right along there. We're going to take those 3 curves and we're going to loft them. Curve, curve, L-O-F-T. Fine, it's a normal closed loft. We want to make sure that that is good there. All right, so that's what we got. Now what we're going to do is we're going to take this surface and we are going to mirror that to the other side of the bottle. Let's start in the middle here and hold down Shift so it locks the ortho in. Now this is one of those cases where in order to make sure that the Boolean command that we're going to do after this works properly, we want to check the direction. dir, and those arrows are facing outward. We want them to face inward. So I'm going to hit enter. And that's good. Let's go to this guy and let's also type in dir. We're checking the direction. Now that is facing inward. Okay, that's good. We're going to just hit enter. Let me check over here one more time. Yep, we're good. All right, so we know that the direction of the geometry is facing in towards the bottle. So now we're going to deselect everything. We're going to type in Boolean difference. Now it says select surfaces or poly surfaces to subtract from. So that would be our solid bottle. Press enter to continue. Now the surfaces or poly surfaces to subtract with, for delete input, let me see. What did they say to do? I guess they don't even say. So we'll keep it on no. So these are what we're going to subtract with. We're going to hit enter and look, there we go. That's what they've done. So let's take these guys and we're going to hide them. And another, actually, we're just going to hide them. Actually, let's delete them. Escape. Delete. Okay, so they're gone. We're going to hide those curves and the label surface curves. Okay, so that's kind of a cool looking label. And next we're going to shell. This is important. Don't skip this step because this is part of what we need to look at when we go to Netfab. So we're going to select the poly surface. We're going to type in shell. And what shell does is shell hollows this out. So select faces to remove. So which one do we want to leave open when we shell this? We're going to hit the top. Okay, and there we go. Oh yeah, I forgot to mention the, let's undo that for a minute so we can go through the command again. The thickness I have here is 0.05 millimeters. I am working in inches, but I can still put in millimeters for measurements, and vice versa. When you're working in millimeters and you want to put something in inches, just make sure that you type in the number and then inches or IN. And with in the case of inches where you want to put in millimeters, you just put in mm. So here we go. Select the faces to remove, leave at least one face unselected. And of course, the rest of it has to be solid because we're making a bottle. So we're going to, again, click that top. I'm going to hit enter. And here we go. So what we've done here is we have hollowed this out. It is solid. And I'm going to use a tool called a clipping plane just to show you real fast what this looks like. Okay. And I'm going to take the clipping plane and I'm going to control it in the front viewport. I'm going to drag it up, but we can see more of what it's doing here in the perspective viewport. Okay, we're pulling it up. Whoop. Yeah, there we go. So we can see that this is not just a surface. It is two walls. There's an inside wall and an outside wall. So basically, what Rhino did with the shell command was create a uniform wall thickness of 0.05 millimeters, half a millimeter. Pretty good thickness for a bottle. Okay, so we're going to hit, oh wait, we're going to get rid of our, we're going to delete our clipping plane. And there's the bottle. So the next part is the bottle top. This part is a little tricky. So I want to, it's another reason I wanted to go over this with you. So first thing we're going to do is we're going to hide the bottle surface. We're going to make this the top detail curve. That's going to be our current layer. And I'm going to hide the surfaces. Now we're going to bring up the top detail curves. And where are they? Oh, I guess it's path curves. No, not that. Label surface. No, not that. Where's our neck curves? Our neck curves should be right up here. Was it over here? Oh. Interesting, because we should have these curves here. Thread curve. Okay, here we go. These are the ones for the bottle top. Let me hide the bottle and these curves. Okay, so the first thing we're going to do is we're going to create the thread curve. We're going to do that. Okay, it says make the neck curves layer. And we've got this helix here already made. So, but they do talk about how to do this in the, yeah, that's interesting. I'm going to hide this guy. Control H hides it. And the same with this, also hidden. So we're going to go to the curve. We're going to use helix. And we're going to choose to go around the curve. And we're going to go use this magenta curve in the middle. That's the curve we're going to go around. And then in the, oh yeah, we have to change the turns to 2. Okay. And then reverse twist, no. Okay, we've got that on no. And in the front viewport, we want to snap for the radius to the green profile curve. That's right here. That's where we want that to be. So we're going to hit that. And there is our helix for our threads. This is actually going to have a screw-on cap, but we're not going to make that part. And okay, so now we're going to extend and scale the thread curve, which is on the curve menu. We click extend curve, and we want to extend curve. So we go extend curve, and we want the type to be smooth, and the select boundary objects or extension length. Press enter for the dynamic extend. At that point, now we select the curve, and we click on the one end, and we want it to be 0.5, and I have that there. And then we click on it again and go to the other end. And then we press enter. Oh, wait. That didn't work. So select the curve to extend. We did that. And the type, before I hit enter, it should say smooth. Now we'll hit enter. And it did not extend. This extend curve is so weird. Okay. So we type is smooth. All right. And now we hit enter. This is so weird. Okay, escape. There we go. Is that the right number of? Yes, it is. Hold on. Curves. So on the curve menu, pick extend curve and extend curve. Smooth. And that's the curve to extend. And yes, that's what we have to do. We have to click on it, not hit enter. We have the 0.5. Now we click on the other end of the curve. And oh, okay, the command keeps running after the first extension, so you do not need to start it again. Press enter. Start the, there we go. I don't think it did anything. This is such a weird command. Sometimes they pick the strangest commands for these examples. Right. So we're going to do this one more time. Select the curve to extend. We need to change it to smooth. Okay. Let's go back here. Or natural. Let's keep it on natural. Type. Okay, so we're going to click on the and 0.5 is the enter, end of extension, or enter extension length. And then we're going to click this curve again. We're going to click over here. Click this again and go 0.5. There we go. Now it extended. Broke history on that one. We're going to right click. Now we're going to use the other curve. And we're going to keep it on natural. And whoop, not that. Why does it keep doing that? Because I want it to be on this here. Not a boundary object. Select the curve to extend. We're going to type in 0.5. We have to do that before we click. Okay, and now these two ends are extended, but you can see that they don't actually stay within the helix. They're a little bit inside. So we're going to actually scale those 2 points out. We're going to make sure that our points stay on. We're going to select this point here. Select this point here and this point here. We're going to go transform menu, scale 2D. And we're going to set the base of the scale to the C-plane origin by typing in 0. All right. And then the reference point or the scale factor is 0.85. We're going to just type that in and hit enter. So what that did is it actually moved them in a little teeny bit towards the origin. Okay, so that's the ends of the helixes now. And that's okay. So then we're going to take this curve, we're going to orient on curve. Okay, we can start typing and then we can pull up orient on curve. And that triangle is actually like way down here. So that's right around the origin point. So the base point for that, we're just going to type 0 and hit enter. And then the curve that we're going to orient it to is this one. But before we click anywhere, we want to make sure we click on perpendicular. And then we're going to put it right here. And this way we can see where the triangle is going. We want it to be facing out so that it actually is a, so it becomes the thread for the piece of, you know, for our bottle cap. Okay. And so if it's not facing outward, you may need to do this flip here with the X flip or the Y flip here. And actually, I'll show you what that looks like. So let's undo this command. We're going to redo the command. We're going to put in 0 for the origin. We're going to select the curve. And now we're going to go perpendicular. And if we needed to flip, we could go Y flip, and then it would point it in the other direction. See what happens? See how when I have the X flip on, the point of the curve is facing towards the middle. Now, because we're making threads for a bottle cap, we want it to face the outside. So let's make that X flip no, and we can see it's facing the correct direction. That's fine. Now we're going to hit enter. Oh, hitting enter brings up the last command. Okay, so the last thing we're going to do with this is we're going to sweep this curve. We're going to use the sweep 1. Yep. The rail is our helix, and then the shape is the triangle. And all right, the seam point is fine. Now we're going to hit OK. Let's see what road-like does to it, though. Yeah, road-like makes it a little more uniform for this purpose. We're going to hit OK. And here's our helix. All right. We're also going to cap this too, by the way. We need this to be a solid, so it will work with the Booleans. So we're going to go CAP, and that says one closed object. Great. So the next thing we're going to do is we're going to revolve those other two curves. Okay. Yeah, let's hide this a minute. Okay. And we're going to go revolve. This is the curve we're going to revolve. We're going to hit enter. We've done revolve a few times now. Okay. Start angle 0, end angle is 360. That's good. All right. So, and this is now a closed polysurface. Great. Let's show that helix for our threads. And we're going to have that go. And we're going to Boolean union those together. Boolean union. And it broke history. That's fine. Okay. See how those threads now go right in. All right. That's fine. Now we're going to revolve the difference for it. Okay. We're going to do revolve again. We're going to choose this. We can use that little magenta line in the middle, or we could just use the ends because these are very precisely done, these curves. So that's the curve to revolve. The start of the revolve axis is this one, this here. We're going to hit enter, 360. That's good. So that is now there. And that is the plug that we need to difference out of the top end of the bottle. So we're going to type in Boolean difference. We're going to select that out of there, hit enter. That was the subtract with. Wait a minute. To select surfaces to subtract from, that should be that guy. We'll hit enter. Now to subtract with, that's where we're going to choose this guy, enter. And it is still there, but we're going to hide it. side. And we can see here in our perspective viewport that what we've made is kind of a little ring. Now we're going to show our bottle. It's right there. And we are now going to take this and union it, Boolean union. Okay. And there we go. What we have here is our bottle. The last thing that you want to do is fillet the edge, F-I-L-L-E-T. Let's spell right for first, Barb, huh? Fillet edge. Okay, we're going to grab this edge here, and then we're going to work with the edge on the other side. Because I did this earlier, it actually still had the measurement in. Normally it would be 1. But what you're going to want to do is once you select these edges, you'll hit enter. Then you can hit set all and put in the radius that you need for the edges. And the radius that it wants you to use in this exercise is 0.25. And we'll leave it at that. We're going to hit enter. And that should be fine. We hit enter again, and there's our bottle. Okay. So at this point, we can close these instructions. We don't need them. But we will need to go back into the assignment exercise and pull up these instructions. These are instructions that are specific to our course. These were not put together by McNeil. They were put together by me. So first thing we do now is we want to, so this file should get saved at this point. We should make it, I'm going to do a save as. I'm going to save it on my desktop. I'm going to call this Barb's bottle. Barb's syrup bottle. Bottle, okay. And I think I spelled syrup wrong, but that's okay. So now, when I go to open these instructions, this way I know I'll find this. So it says, open the squeeze bottle. Select the bottle and go to the properties panel. That's this panel here. And it should say closed solid poly surface or closed surface. If it doesn't say that, you're not going to be able to print it. So before we do anything else, what we need to do is we need to take this and let's check the edges. We're going to go show edges and make sure that there are no naked edges. All we have are, and we'll, depending on which little button you have chosen here, the edges will show pink. So if we have all edges, this is going to show us what all the edges look like. What we really are interested in is naked edges. So we don't have any naked edges. That's great. It says up here what we have anyway. It says it has 50 edges altogether. No naked edges. Great. That's good to know. I did show you about the clipping plane already, but we can do that again here. Let's go clipping plane. Okay. And in the top viewport, you want to draw a rectangle. And we can see that that clipping plane fell right to the floor there. So in the front viewport, we can take it and lift it up. And we can see how this is, oh, here we go, let's swing around here. When we move this clipping plane up and down using gumball in the right or the front viewport, we can visualize the wall thickness. This is really important. And you can see that Rhino did a great job making a very uniform wall thickness, even down to the bottom. Okay, so that's great. We checked that. Now, before we export it, let's get rid of that clipping plane, delete. We should check the size and the volume. And this is something that we need to do every time we send something to be 3D printed. So let's use the bounding box first. And I like to have the output be either curves or nothing. So I have it on curves now. I'm going to hit enter. And what it did was it drew a box around the object. And it also gave me dimensions. This is 3.9 inches wide, 2.5 inches deep, and 7.75 inches high. All right, that's pretty big. It would fit in our Form 2 printers if we needed it to. I'm going to get rid of this bounding box. And now the last thing, and we already did check for naked edges. We had that there. Now the last thing we're going to do is export this. We're going to go File, Export Selected. So, because remember, you have to select it first, then we export selected. We're going to now take this, and I showed you guys this the other day, but I did it pretty quick, so I'm going to do it again. STL file. And now we're going to call this we're going to go back to the desktop, and we're going to make this we're going to call this bottle to print. Okay. To print. Okay, and it's an STL file. It's very important that this number, the maximum distance between the original file and this polygon mesh, is 0.001 inches. I'm going to hit OK. It should be binary. That's great. I'm going to hit OK. Now I'm going to close Rhino. We're going to do no. And now I have to bring up Netfab, which I just downloaded so that I have it in my, there we go, Autodesk Netfab. And it's starting up. Super, super important before we do anything with Netfab always is, of course, we have to sign in with my Autodesk ID, which is the same right now as my Temple ID. So because you guys have Autodesk through Temple, you can also do this if you wanted to, if you're working on Rhino on your home computer. Okay, hopefully that's the right. There we go. Yeah, okay, discard, okay. So that's the privacy thing, whatever. Okay, so the first thing that happens when it comes up, there's this My Machines. You're not attached to a 3D printer. Don't worry about it. You can hit cancel or just close the window. The next thing that is super important is go to settings. You want to go to settings, then choose settings. Now at this point, it's important to check the unit of length. Millimeters is the default. So if you're working in inches, and you are for this assignment, you want to change it to inches, then hit save at the bottom. Okay, now we can add the part in. And I'm going to go to my desktop. I'm going to get that bottle to print STL file and put that in here. Now, before it goes in, we notice that we have this green check mark. That's great. That means that it's, on first glance from Netfab, it says it looks pretty good. So here we go. We have the bottle in Netfab. By the way, I'm going to move this a little slow. I'm going to move this so we can also look over here. Now, okay. Important to check we're using the same unit of measure. We did the add part. And now the next thing we're going to do is we're going to, we want to make sure that that's selected. In Netfab, things are selected, they're orange, and they have these boxes around it. We're going to hit repair part. That's that red cross. What we'll do now is it does say that the mesh is closed and oriented, that it looks good, but we're going to run a repair script anyway. We're going to run the simple repairs since everything looks good. We're going to hit execute. And after it executes, and you did see it go through a very quick, it was a very quick status bar. We're going to hit apply repair, and we're going to remove the old part. Now that may sound a little like not a great idea, but you've already saved this file elsewhere. So we're going to just remove the old part. And now it changed the name of this part to bottle to print repaired. That's great. So now that it's repaired, we can right click on it. We're going to export that part as an STL. Okay. And here we go. It says bottle to print repaired STL, and it's going on the desktop. I have this lovely green check mark here, which means I don't need to do anything else. If you don't have a green check mark here, that doesn't mean that you can't export it. As a matter of fact, you probably should anyway. You would just want to put in 001, hit the optimize button. It'll run through another check. Now it's saying, oh, I don't know if I like that. We're going to hit optimize again, and then we're going to hit OK. All right, and now I'm going to remove this file. I'm going to hit that red X and remove it out of Netfab. Yes, I do want to remove it. It will ask me. And now I'm going to add the part back in, but I'm going to add back in the repaired one. See how I have two here? I have bottle to print, and then I have bottle to print repaired. That's the one I exported out of Netfab. I'm going to hit open. And look, I've got that green check mark. That means this file is still good. That's great. Instead of adding it back in, I'm going to hit cancel. And that would be the part that I would 3D print, or in this case, you're going to, and by the way, we close Netfab without saving anything. Okay, it says you got a project, do you want to save it? No, we don't save anything with Netfab. We don't use Netfab files. We just use Netfab for repairs. So now the part that will be submitted for this week's homework is the, where am I at? Desktop. That's the downloads. Let's go to the desktop. Will be the repaired file. And what I'm going to do is I'm going to open them up in Netfab, and I'm going to see what's, how they are as far as repaired. So this is basically the main part of the homework for this week. I know you also have, I believe, let me see, in the assignments, we've got, I think we also have the creating surfaces. So that's the retro phone. And then we have the bottle. Okay, continue that until you reach the completion of the modeling for the bottle. Once you do the fillet edge, don't worry about the rest of the bottle. Don't do any of the rendering that, after we finish, they talk about rendering and the labels and the properties. We're not, or the cap, none of that. We're not interested in that. All I want is this bottle with the thread and filleted edges and run through Netfab, and that's what I want you to submit. And the reason we're doing this is because when we get back and we have our 3D printing, we're going to be putting together our 3D printing files for the ring project. And this is the same process that we have to go through with that. And it is important to understand it and go through it at least once before we go through the, before there, to submit our rings. Okay. Do we have any questions? That was a lot of information, but I know that, with break and everything, and I'd like everybody to stay up to date with the assignments. I figured that I would give you guys a quick demo on it and see how, if you had any questions that I could answer before we break for break. Nothing? Okay, I am going to stop recording. Okay. And